recap of our set stuff that we did a couple days ago. We did it last week. And so I just want to start with a little bit about our set notation. So we always use capital letters to denote a set. So since that's a capital A, it's a set A. We use, if we're talking about just any general idea of an element, we use a letter. So suppose we have A is equal to, and it doesn't have to just be letters, but, so actually let me use the numbers. A is 1, 2, 3, and for some reason also 7. And so if that is, we have a set. Remember, we have that blown out slide or the breakout slide where it has all of these little bits. The set containing, and so we always use these curly braces. And I always had, my math teacher always said braces look like faces. But we always use our braces to denote a set. And then we have some symbols. We can say that 1 is an element of A. So is an element. But 4 is not an element of A. So that is not an element. And then we have just a couple more notations. So I'm going to rewrite my set A. A is 1, 2, 3, and 7. And suppose B is 2, 3, 4. And let's give C 2, 3. So we can talk about subsets. So C is a subset of A because both 2 and 3 are in A. C is also a subset of B, and so this is a subset. And actually it is a proper subset because C, it doesn't have all the things of A, so they're not equal. So just like we have a less than, we have a proper subset, and then suppose I say D is 2, 3. C is a subset of D. So that means it can be equal. You could also say C is a proper subset of A, just to emphasize that it's not equal. So those two are equivalent. So just kind of a summary of our notation. We have our element and not element. We have our subset, which is subset or equal to, which looks like this. And then you could also say it's not a subset. We have proper subset, which looks like this, or is not a proper subset, which looks like that. And then we have just a few more. If we do A, take away C, you get A. 1, 2, 3, and 7. And you take away all the things in C, 2 and 3, and so you're left with 1 and 7. So A minus C is that. And we have a couple more. We have our intersect, our union. So now B is 2, 3, 4. C is 2, 3. And A is 1, 2, 3, and 7. A intersect C. means only the things in both, which means 1 isn't in both, 2's in both, 3's in both, 7 isn't in both. And so we get something that looks like that. A or B would be something that's in either one. It doesn't have to be in both. So for A or B, A has a 1, they both have a 2, they both have a 3, B has a 4, and A has a 7. And that's called union. Remember, I think of this as or, and I think of this as and. Because then they start to look like our logical and our logical or, right? They open the same way. And so we have our intersect. And then the last one is the complement. So suppose we're talking about, so we have A, B, so A, B, and then we have to figure out where C is. So A has a 1 in it. A and B both have a 2. A and B both have a 3. B has a 4. A has a 7. And then and C has a 2, 3. So that means that this piece here, the blue wedge, is C. And so suppose we were talking about all of the numbers, so we use U to be the universe, or all possibilities, is all of my natural numbers such that n is going to be between 1 and 9. It's a natural number, and so we have 1's there, 2's there, 3's there, 4's there, 5 lives out here, 6 lives out here, 7, 8, 9. And so here, suppose we wanted everything that wasn't in A. So everything that's not in A, it's going to be this 4, 5, 6, 8, and 9. We have something like that. And so that's just kind of a recap of all of this set notation. And so now I'm going to go through a couple specific examples, and one of them I've already done here. So here on the next page, I have a slightly different set. I have an A, and actually let me just change their names because I already used A and B. We'll call this W and X, again, capitalized. So W and X, and again placing it in, W has a 1, they both have a 2, X has a 3, they both have a 4, X has a 5, and W has a 6. And so that's how we fill out a Venn diagram to help us make sense of problems. And so now we have a couple questions. It says, and so what I'm going to do is work through a couple parts of your homework. So here for 2, 3, A2, we have B minus A and B intersect not A. And the question is, are these two always the same? So call this A and call this B. So B minus A is going to be everything that's inside B, but it isn't also an A, right? Because that's what on our previous slide was common to both. And so if we look at that piece right there, that's B minus A. It's everything in B, taking away everything that's in A. Now, it says compare that to B intersect not A. Well, let's first draw what not A looks like. So not A is everything that's not in the circle. And so it's like all of this stuff. That's not A. And it says we'll intersect not A with B. So it says what's common to both? Well, it turns out what's common to both is this part that's doubly colored that looks like that. So that's B intersect not A, which is the same as this one, B minus A. And so these are always the same. Because what it has you show then is if that's not the case, we give a counterexample. So there are a couple more like that, and they're kind of this general. So draw those Venn diagram pictures, you should be good. For 2-3, B1, it says we have some sets. W, which is the whole numbers. A, which is our 2 n's plus 1's, our odds. Our 2 n's, which are our evens. And then we have our counting numbers, or our natural numbers. And so it says, write the names of these the simplest way. A says, what am I left with if I take whole numbers without A was our odds? So if I have my numbers and I take away all the odds, what am I left with? Those are the evens. And the evens we called B. So this, W minus A, is equal to B. Or then A intersect B says all of the things that are in both A and B. So A is our odds, and B are our evens. So what number is both even and odd? Well, by definition, a number can't be both. And so the intersect of those is our empty set, because no number is both even and odd. Right? And again, that's why I like to think of intersect as and, because it says what is in both A and B. The answer is nothing, because I can't have something that's both even and odd. And now here again we have this more general, compare these two, are they always the same? And it says if it's not, give a counterexample. If I start with A and take away everything in B, or I start with B and take away everything in A, am I left with the same? Well, let's go ahead and use our A from earlier and see if that is helpful. We said that A is 1, 2, 3, and 7, and B is 2, 3, 4. So that means A, take away B, is everything not in B, so we are left with a 1 and a 7, and then B, take away A, is take away the 2, take away the 3, and we're left with a 4. Well, are 1, 7, and 4 the same set? No, they're not even the same size, so they certainly can't be the same set. And so they're not equal. Sometimes they might be, right? Suppose we had, if they were both the same set, if they were both the empty set, right? There are weird instances where this is true, but they're not equal. And then here we have another one where it says B minus A and B union A if B is inside A. So B take away A and B union A if B is inside or equal to A. So let me draw a picture. So I have my universe. I have my A and I have my B. There might be nothing in this space that is only A and not B, because it says it can be equal, but we have something like this. So B minus A, everything in B is also inside A. So B minus A has nothing in it. If you want a concrete example, let A be 1, 2, 3, and let B be 2, 3. That'll match this picture. We'll have a 1, 2, 3. So B, take away everything in A, take away the 2, take away the 3, take away the 1, it wasn't there, we're left with nothing. B union A is just everything in B and everything in A. 1, 2, 3. Not equal. And so there are really two or more ways you can proceed through these types of problems. Start with a Venn diagram, and that is one way to start, or just start with an example. Right? We can use examples to build our intuition feeling about it. So if it's helpful, just pick an A and B. Do something and see, does it work here? And then try to see, does it always work? Or maybe is there a special case where it doesn't? And now the last one, we have two more. So again, draw my universe. The universe, I have A, B, and I'll go ahead and draw another one. Actually, I'll draw a couple. So for this first one, it says it's not in A or B. Well, this piece here, both rings together, is A or B. And if it's not in there, it's got to be out here. So it's that piece. So that's A or B, not. Not A or B. And then if we have not A, so let me go ahead and draw my A and B again. I'm not going to put the labels, but I'm going to keep A on the left, okay? And so not A is everything outside of this. So that includes that bit of B that wasn't in A. And then if we take not A, or not B rather now, we have the related one over here. So that's not, whoa, can't read that, not B. So this covers everything but the middle and A's circle. And this covers everything but the middle and B's circle. So if I take their union, something that's in either one, well, in this one, this part's colored, and in this one, that part's colored. So what we end up having is the only thing that's not colored is that middle piece. And so let me draw you another one. That really middle sliver. And that middle sliver has a name. It's B intersect A. So the only thing that's not filled in is that middle sliver. B intersect A. And is this picture and this picture the same? It's not. And then our last one, A and B or C. And then A and B together or C. So now this will be our first one, the 3. A, B, C. A, B, C. B or C is this piece. Let me at least label one of these. So we have A, B, C. I'll label both. A, B, C. B or C is this piece. I can shape that in. And then A intersect. And so A is this circle. And then the intersect is that part that's common to both, and that looks like this. It looks like this. So we have this intersection, and it looks something like that. So A intersect B or C. And then for our other one, now we have A and B. So let me use different colors. A and B is that stuff that's common to both. And it says it's A and B or C. Well, C is all of this. And so we end up with a circle with this little bit on top. And those pictures aren't the same. This shape is not the same, so those are not equal. So that, I think, should help get you on the right track. I had originally planned to include more of this Venn diagram stuff when we were talking about sets, but I don't remember. I think we ended up spending more time on something else, and I didn't have a chance to go back. And so